the last part of this module file is about water-sensitive urban design. With this part we will finish the course also, and this part is just a complement to the rest of the contents, because we have talked a lot about the importance of the energy, of the materials, of the environmental policy of the construction companies, but we need to talk also about the importance of the water, the importance specifically of the rainwater in our cities. The rainwater in the cities is treated at the moment as wastewater, and it's directly from the clouds to the sewer system. So we are taking a natural resource, a very valuable natural resource, and we are just waste it without any use. Also related with this incomplete water management in the cities, in the conventional urbanism, is related in the heat island effect. The heat island effect is the increase of the average temperature in the city centers. The main reason is the imperviousness of the surface and the use of concrete, asphalt, and different materials that retain the solar radiation. But another reason, another cause of this problem is the lack of water in the city centers, the lack of water bodies that help to regulate the temperature in a natural way. And this means also a very important energetic consumption related with air conditioning during the summer. And this is a quite important problem that is being considered in the most important cities in the world. For example, in Tokyo, in Japan, they were able to irrigate, to water the streets in order to decrease the temperature of the city center. Anyway, coming back to the problem of the water, we have to try to avoid the treatment of the rainwater as a wastewater. We have to come back to the natural management, to the 20th century water management, because it's just in the last hundred of years when we have created all the water supply systems, and we have get used to the luxury that means to open the tap and obtain potable water. The previous years, nowadays in farms, the rainwater is still considered as a natural resource. So when we talk about water harvesting in the buildings, we are not saying nothing new. 2 centuries ago, it was quite normal to do this in any building in the world. But then we changed this because it was very easy, very comfortable to obtain the potable water. But this is changing. We are realizing that the water, like other natural resources, like fossil fuels, is a limited resource. So we have to change the management of the rainwater now. And this is a very important point for the urban regeneration. In order to change this, there are several philosophies or several names that appears to call or to refer to the same techniques. Okay, in the United States, for example, all the things started with the best management practices, specifically the stormwater best management practices. During the construction process of any infrastructure, we have to deal with the runoff, with the stormwater runoff. And to do this, we use temporal drainage techniques that have to be as natural as possible. These best management practices have been developed, and nowadays they are used in the urbanisms. And even they have used it inside a bigger or more important philosophies, architectural philosophies, like the low impact development. The low impact development in the United States is the philosophy that is looking for maintaining natural characteristics of a catchment after the urbanization. This means that if we have a forest, a field, and we are doing different buildings in this area, the runoff has to be the same. Then we are preventing problems like flooding or diffuse pollution. And we are making that the urbanization doesn't change the natural hydrological cycle, water cycle. This is very difficult. In other countries like the United Kingdom or Australia, we are talking about water-sensitive urban design, which is very direct, very clear. We have to take into account the water when we are designing any part of the city or a new part or an old part that we are regenerating. And the techniques that we are using there are talking sustainable drainage system, SAT. And finally, in Ibero-America, Portugal, in Spain also, we are talking about different names for the same techniques, for these techniques that help to deal with water. We are talking about mejores prácticas de control, also about técnicas de drenaje urbano sostenible, TEDUS, or even sistemas urbanos de drenaje sostenible, in order to use the same acronym that in the UK, SAT. But all of this has the same objective, which is to deal with rainwater in a natural way. Just to give two examples about these techniques, about SAT, I would like to talk about swales. Swales are carpets made of grass. We are using vegetation instead of concrete in order to collect the rainwater from the streets and to transport it to the next treatment system. Okay, that could be another SAT or could be just a connection to the conventional sewer system. Okay. With this green carver, we are able to reproduce the advantages given by natural rivers, because we are creating an effect of filtration and also evapotranspiration. And finally, the transport of the rainwater is slower, so we are preventing problems like flooding in the city. This is quite difficult to do in the old cities or the city centers, because you need a lot of space in order to construct this. You need also a lot of space for the wetlands. Very good example of wetland, of artificial wetland, is in Santander. In Santander, the city council invests a lot of money in the construction of the Llamas Park. In this park, you have different water bodies, one which is quite artificial, but another one which is very natural. It's a completely artificial wetland that is proving year after year how the urban biodiversity could be improved using these techniques. And you can also imagine the benefits for the society. Just to walk around this natural area is very good for the citizens of the city. This park is the second most important area in Santander. You have to consider that previously to the construction of this park, this area was completely degenerated. It was solid waste disposal, mainly construction debris, and it collect a lot of wastewater effluents. So the regeneration of this area of the city was complete with the construction of this park. Another example of SATs, probably the most complete system or the most complete technique, are the permeable pavements. The permeable pavements, sorry, are not only reinforcing grass. They don't have to be green always. They can be asphalt or concrete, but permeable, porous asphalt, porous concrete, in order to make it possible to pass through the material all the water. And with this, we have the option to decide about the destiny of the water, the destiny of the rainwater. If we only want to obtain more time to avoid the peak of the storm event, to prevent flooding, we can use just simply a subsurface drainage. Okay, just the time that it takes to the rainwater to pass through the different permeable layers is very good for the wastewater treatment management. But probably the most interesting way of deal with this water, with this rainwater that we are filtering, is to do water harvesting in the streets, in all the surfaces of the city. We can do this in two ways. We can create artificial deposits in the soot base of the pavement, or we can recharge the natural aquifers with this water. This is very important. For example, in Mexico City, when we take a lot of water from a natural aquifer, the land even decreases the level, and we have a serious problem because of the impervious. The natural recharge disappear. So with these techniques, we are able to maintain the natural recharge of the aquifers, and this is very, very important. Some examples of permeable pavements are found in the north of Spain, also in the UK, a lot of them, but I would like to show you some photographs. The first one is in Gijón. This is the car park in La Guía Sports Center, and all of these 700 bays, car park bays, are permeable. Finally, I would like to finish with this conclusion. The urban regeneration is not complete without an hydrological urban rehabilitation. We have to take advantage of the maintenance, the conservation, the different construction actions that we will put in practice in the city center in order to change the hydrological model, in order to improve the urban water cycle. And we can do this mainly using permeable surfaces, not only in the pavements, but also in the roofs of the buildings. Also, to fight against the heat island effect, these are a very good solution. And if you look for the concept of cool pavements, you will find that the pervious pavements are there also. So for the construction companies, it will be very important to know how to do this in the future.